Right, this is your old regulator like you used to have a long time ago with FRBI. Now, I may have these backwards, but that's the order that they go in. If I remember right, when you plug the connector in, it was FRBI. That's why I put them backwards on here, because if you turn the connector over there, it would be. F's going to the field. R is actually, if you got an alternator stator, and this is the part around the outside. See that part around the outside? It looks like a circle. It's over on the right. Okay. This right here, if you got a winding like that, you notice it's got 3 junctions, right? This right here is a delta wound stator. Why do you call it delta? Because it's shaped like a delta, which is a Greek letter, yeah. Okay, so, and our D actually has got its roots in that. But anyway, here we got this. Okay, so off of one leg of this, well, let me draw it a different way. Well, you could draw it this way, but there's another one I'm going to show you though. Let me just show you the other one. There's a Y-wound stator too. They're tied together in the middle, but it's still got 3, right? Off of one of these is going to go to the R terminal. And you're going to have like 7 volts here. And if it sees 7 volts here, then basically it turns off the light. If it does not see 7 volts here, it assumes the alternator is not charging and it turns on the light, even though the alternator may be charging, right? And that's the way that works. And this is the old regulator that was mounted on the fender with a, with little ears and all that stuff, and it had to be grounded really good through this. So basically you had 5 terminals. You had ground, you had field, you had your R terminal, you had your battery, you had your ignition. Now in the olden days, when I first started learning about this stuff, the difference between a Ford and a Chevy, well, some of them had the, basically some of them would have the field hardwired to power and would be ground in the other side, which is typically what we see. But some of them had, like on some of the tractors and everything, some of the Motorola alternators, I guess it was, actually would dither the power and have the field hardwired to ground. But this is not the field. The field spins inside of this. Now we're going to take this right here, and we're going to wind it all up into a big circular loop right here. We're going to put this laminated core in there, right? And we're going to put 3, and I'm drawing this out of convenience right there. And these things right here are going to be hooked to the center of these diodes. Three going that way, 3 going that way. I'm not really doing that good. But anyway, if you look at it on a schematic, what you're going to see is you're going to see 3 of these with 3 diodes pointing that way and 3 diodes pointing that way. Now, what that looks like, and somewhere I've got this, in the real world, is this. See that? There's diodes. You notice this right here, these are grounded, and this one right here is insulated, and it's actually the one that the power comes out of and goes to charge your battery. But you notice on this side, you've got 3 connections. You got 3 connections right there, 1, 2, 3. Those 3 connections hook to the 3 terminals on the stator. So this part right here is that part right there. You got it? That's the rectifier bridge. Now the 3 terminals on your stator, which I'm just drawing this kind of silly, are going to go here, here, and here. All right. Only one of those goes to the R terminal. All right. Now then. Now what General Motors did, well, Chrysler actually came up with a voltage regulator that was a potted thing. It was a square thing, and it had a short. It had a sort of a connection like that, and it had 2 terminals, and it was grounded, by the ears where it was mounted and all that kind of thing. And so basically what you'd have on that is you'd have, this will be ground, and one of these would go to the field, and the other one I think went to power. There was one that was taller and one was shorter. It seemed like a short lead was positive or something like that. So those voltage regulators there, there's several different kinds. But as you read in your handout, it's all about regulating voltage anyway. So basically what we want to do is we want to make sure that the voltage is regulated within a certain band. And so we got to have an alternator that can handle it, can put out enough to where it can handle all the accessories and all the load and all the, the stuff that's going on there. And let's look at the primary difference between a generator from the 1950s and an alternator, which is also called a generator today, even some manuals and stuff. Is what's it called? What's the difference? What's the difference in the field on an alternator and on an old generator? You know the old generators that look like a starter and all that? The difference is that they had brushes like a starter, and the field was in the middle. And whenever you were, I'm sorry, not the field wasn't in the middle, the field was around the outside on those. So the field coils generated the magnetism where the power, as this part that spins in the middle was spinning around, sweeping through all of this, it was creating that power. Matter of fact, they call that a dynamotor, if you'll look. And so it would come out of that, the power was being created in this part that was spinning, and it was leaving the part was spinning through the brushes, and it had to come out as DC current because of those brushes sliding on that commutator. And a commutator is like this right here. See? Now I could actually turn one of these little power window motors into a generator if I hooked up to the two brushes. You can take any DC motor, hook it up to the two brushes. You could spin this with a drill, and it would create all kinds of power, because you got on the newer power window motors, you got permanent magnets out here, which is the same thing. The field coil had big, bands of copper wrapped around these cores that were put through, screwed to the case. Anyway, that's what that was all about. So the field is around the outside on an old generator, and the field is on the part that spins on one like that. And move that, Dustin, so it won't fall off the table. That's a little too close to the edge of the table for comfort. Fall on somebody's foot. So anyway, the point I'm trying to make is that's the difference between the two. So alternators produce alternating current. What's used to rectify the AC current back to DC current? Diodes, and you're going to have them arrayed in a rectifier bridge, which is what this is. That's a rectifier bridge. Whenever you look at an alternator, you're going to see that. You're going to see it, and there's several diodes in there. There's like 6. There's 3 positive and 3 negative in this one, and all that. Actually, there's 6 in there. Anyway, the long and the short of it is that's what that's all about. So what was the difference between the logic module and the power module on mid-80s Chryslers? Anybody know? What was the logic module on a mid-80s Chrysler used for, according to the thing you read?
Charging rate decision. Charging rate decision.
Well, basically, the right answer to that, and it's in your handout, is that the logic module was used for calculations, and the power module is what did the work.
I literally wrote down what was in the pamphlet.
Yeah. So what? And I thought this was kind of funny here. What was the early made-up funny name some mechanics had for the engine controller? Fred. What's Fred stand for? Frustrating, ridiculous electronic device. And he even talked about, Fred. Occasionally he'd mention Fred. They let Fred have control of this. Okay. So number 5, maximum alternator current output is limited for what reason? In other words, what is it that affects it as far as alternator construction goes?
We got a pocket. Oh yeah.
Yeah.
Is it the local is the alternating factor?
Well, sort of. Yeah, you're close, but the size of the fixed stator is part of it. Remember this: the rotating rotor winding and the speed, which would be related to the size of the pulley. And that pulley on that alternator I got laying on the table there off that Lexus is larger than what you usually see, because they didn't want that. I mean, they figured it was turning fast enough to produce what it needed to with that bigger pulley. Now, a lot of the times, if you're really tacking that out on your car, like if you're really going fast, you're going to be spinning your alternator as much as 14,000 RPM. And excuse me while I answer my phone. Hello. Hey. I'm in the classroom trying to give a lecture. Alrighty. All right. Okay. Now then, number 6. Let's look at number 6. What's the difference between the charge required for a cold battery and the charge required for a hot battery?
Batteries need less, cold batteries need more.
Yeah, colder batteries need voltages close to 15 volts, and warmer batteries need lower voltages closer to 13 volts, else they'll overheat. And you might see that in a lot of these cars, they got these boxes over the batteries, and they'll also have these bubble wrap coatings around them, and that's to keep the battery cool. They don't want the battery getting any hotter than, keep it as cool as they can. Of course, under the hood, it's going to be pretty doggone hot just by default and everything. Number 7, what is standalone regulated voltage control?
RVA?
Huh?
SARVA.
This is my fault for the own logic function.
Well, it's acting in concert with the PCM and the BCM during the CAN bus. It's a current sensor. You're going to see some of these newer cars. You know this little current sensor that we put around the cable on the battery when we're hooking the charging system tester up? There's one of those built onto the vehicle. And it's got multiple wires, and it controls the field wires connected to the voltage regulator and the alternator. So basically, it's actually making sure that you're feathering exactly the right amount of current in there, not to overheat the battery, but to keep it as strong as it needs to be. It's pretty good idea. It's something General Motors came up with. And but you're seeing it on more and more of them now. And it's not unusual, in hybrid vehicles, a lot of times you'll see a current clamp around the wires leaving the, some of their electronics. Okay, number 8. According to Dave, what 2 things should you check first under the hood when investigating a charging system concern?
The voltage drop between the battery first and
Yeah, you need to know what kind of how healthy the battery is. You need to find out as much as you can what kind of health that battery's got. And then other times you need to know what the voltage drop is on both sides, the hot and the ground. And that'd be charging system voltage drop. So you go from the big lead on the alternator to the positive battery terminal. You want to know how much voltage is getting lost between there. Then you go to the case on the alternator, the negative battery terminal, how much is being lost there. If you're losing something there, you need to clean things up and see if you can get that down. And so that was number 8. Okay, number 9. Why is engine RPM not relevant when checking the 12-volt battery charging system performance on a GM belt alternator starter system? Where does the voltage come from that charges the battery on one of those systems? Does it have anything to do with the speed of the engine?
From the battery?
From the high voltage battery, and it goes through a DC to DC converter. And so it can actually, the contactor's closed and it starts shooting out 14 volts from even when the engine's not running, that big battery can put voltage out through it, put current through its DC to DC converter and charge the battery. One of the ways you can tell your contactors are closed on one of those systems is when you take a voltmeter and you hook it up to your battery, and you energize the system and see if it's got 14.5 volts there. Pretty easy to do. What is an IGBT?
insulated
Say it loud. Everybody needs to be able to hear you. What is it?
insulated. Yeah.
Say it like you're mad. Like you're mad at your boyfriend. Say it. Say it loud. You're right, but I want to hear you say it loud.
Gate. Insulated gate bipolar transistor.
That's a little bit better, although you wouldn't intimidate anybody with that voice. Okay? All right, there we go. All right. Now then, now that we're through with this charging system business, and incidentally, you guys are most likely going to have to fix a charging system as a part of your final exam, so you better study and brush up on that and check some of them and all that kind of stuff. I had several worksheets where you're supposed to use the charging system tester to go in there and actually check several charging systems and get used to them. Well, let's look at this particular one here. What I got to do is I'm going to start a new